Okay, folks, here's our last video. It's the 2017 number 3 question. I know it says no calculator allowed, but we will be using our calculator as well. What you'll notice is that they've given me a graph. The graph is of f prime. So f prime are the values of this graph. And I don't know I need all this info, but I'm going to put that anyway. F double prime would be the slopes. And the integral of f prime, integral and derivative cancel, would be f, which would be the area. So I'm going to do, before I even start this problem and read all the info on there, I'm going to go and find the area of the regions under the curves. So I'm going to move back a page, 2 pages maybe, and here's what we have. So we have this first region right here. Let's make our pencils thicker, hold on. How's that? So this region right here would be 1/2 base times height, which would be 1/2. The base is 1, 2, 3, 4. The height is 2. Yep. Cancel, cancel. The area of this one is 4. Okay, I'm going to go to this triangle over here now. Let's go in green. Here it is. And I don't know that I need to do this, but I'm pretty sure I am. 1/2 base times height. 1/2. 1, 2, 3. Times the height of 2 equals 3. And now my next region, I'll do in blue, is this one right here. I have a 1/2 circle. And the form of the first circle is pi r squared. The radius on this circle is 2. So pi, 4 pi would be for the whole circle. 1/2 4 pi would be for this half a region right here, which would be 2 pi. And it's below the curve, so it's going to be negative 2 pi. And we've now found the 3 regions of area that are available to us. I don't know that I need them. I probably do. Where these things get tricky are, you have to make sure you get the correct radius. The correct radius is 2, not 4. We use that, we cut it in half. And let's see how that info helps us in the future. Okay, so we know that f of -2 they gave us is 7. And this is classic. They're just going to give us points, and they're going to, give us area as well. That's 7 minus f of -6 equals whatever the area is from -6 all the way to -2. Now, if you look at the picture, -6 to -2 is 4. So 7 minus what equals 4? 7 minus 3 equals 4. So f of -6 equals 4. We're going to do the same thing on the next part of the problem. Let me duplicate this page. Hold on. So the second part of the problem asks the same type of question, but they want f of 5. So -2 is my anchor point because of this piece right here. So the integral from -2 to 5 of f prime of x equals the integral of f prime, which is f of x from -5 to 2, which is f of 5 minus f of -2. I don't know what f of 5 is. F of 5. I know that f of -2 equals 7. Equals the area under the curve from -2 all the way to 5, which is here. And that's equal to so the area under that curve is equal to -2 pi plus 3, because it's the area from here all the way to here. So to find f of 5 equals -2 pi plus 3, moving the 7 to the other side, plus 7. So I can leave it like that, or I can write f of 5 equals 10 minus 2 pi. Any answer is correct. no, sorry, here or here works out for that problem. Okay, let's take a look at part B. On what intervals is f increasing? Well, f is increasing when f prime is positive. So I make a little number line map. F prime and f. Well, let's look at our hold on. So let's look at f prime. When is f prime 0 or undefined? Well, f prime is 0 at -2. You can see right there, this is f prime, it's 0 at -2. It's also 0 at 2. And it is 0 at 2, 3, 4, 5. 0, 0, 0. F prime is the value of the graph. It is positive before f prime. I know you're saying that the graph is going down. The graph is f prime. So it's the height of the graph. That's why it's positive. Between -2 and 2, it's negative. Between 2 and 5, it is positive. So on what intervals is f increasing? F is increasing between -6 and -2 and 2 and 5. See number line graph. That gives you enough to know what's going on. That's the number line graph. You don't need to do any more work than that stuff that's right there. Okay, let's go on to part C. So very often, if you have a 4-part question, part 3 will rely on part 2. Find the absolute minimum value of the closed interval -6 to 5, justify your answer. So I have my number line graph here. I know my graph is going up, and then down, and then up. So the minimum value is either at the start of the function or at this bottom of the function. The start of the function is at -6, and the bottom of the function is at 2. So the minimum is either at f of -6, which we found early on in the problem. We found that to be 3. Or at f equals 2. Which is equal to 7 minus 2 pi. The one with the lowest value is this one right here. So the minimum for the graph is at f equals 2, which is at 7 minus 2 pi. So the last part will try to be tricky, but it might not be that tricky. Find f double prime of 5 and f double prime of 3, which means this graph is f prime. So f double prime is the slopes of this graph. So f double prime of 5 is -5. Ooh, erase that. F double prime of -5 is a slope at -5. Now, if you look at -5, -5 is here. What happens is a lot of people look at 5 and see there's no slope because it's not a point that's continuous. But -5 is. And the slope at -5 is the slope of this line, which is down 2 over 4, which equals -1/2. That's the slope at -5. And then the slope of f prime, which is that graph at 3, it's a slope at 3. 1, 2, 3. There. Does not exist. And y, all you got to write is cusp. That's enough to get the problem totally right. Okay, that's our last problem. I'm going to post it. If you have any questions, let me know. Bye.